Okay, so yesterday we saw that you did not have to have the same width for your rectangles in order to use the Riemann sum and use our method, okay? However, having equal widths is a little easier. So anytime we can, we want to, all right? And for our purposes, unless you're told use this for C sub I, just do equal widths, okay? We're not going to get into the more complex thing unless you're specifically told to, and you'll be told what to use for C sub I, okay? But what we're going to do here is practice just one more, but starting from the integral notation, okay? Before we were given a function, we were given an interval. Now we're given a definite integral to find, okay?
Right.
And here we're going to use even subintervals because the only time we need to use different widths is when we can't get the sums down to I squared, or I cubed. Then you got to get creative, okay? Now this one, it says check using a calculator, but we can actually check our answer here using geometry.
Wait, don't we know more than I squared and I cubed?
We know constants.
Number of,
There might be some formulas out there, but we only learned I squared, and I cubed. So now we're going to go from -2. This is a line, so if I plug in a -2, we're up here at 8. Okay, so there's that point. And we're going to go all the way to 4. So here's 2, 4. At 4, we are at -4. Okay? So we get our line here. Okay? And I can approximate, or actually I don't even need to approximate, I can actually find the value of this integral the way we were with some of the homework last night by finding the areas of these triangles. Okay? Now,
what are you trying?
where does this hit the x-axis?
2.
At 2. Yeah, so that's at 2, 0. Okay? And the area below is going to be negative. Okay? The area above is going to be positive. So this triangle right here, it's base of 4, height of 8, so the area is a plus 16. Okay? Here, this is a base of 2, a height, if you will, of -4. So the area is, hang on, the area would be -4. So we're going to say that the integral from -2 to 4 of 4 minus 2x should equal 16 minus 4, which is 12. Now we're going to find that using our limit process as well, just for some more practice here. Okay, so since the area below is negative and the area above is positive, it'll cancel out some of it, and what we end up with is what's called a net area. All right, kind of like when you get paid, you have your gross pay, you get taxes taken out, and what's left over is your net.
Okay.
All right, so here we have a net area of 12. Okay, and that will have specific applications, especially if this were a velocity function. This means we traveled in the positive direction 16 and the negative direction 4, so we ended up 12 units away from where we started. That's how we'll apply this eventually. Okay? Yeah, David?
I was just thinking, if we're in the bottom left of the axis, is that not a positive area? We're doing -2 times -4?
No, the x you would always look at as positive.
Always.
Yeah, because you'll move left to right. Alright, but that is the answer we should end up getting. Let's go ahead and practice our process, okay, using the Riemann sum with equal widths. So, the b minus a over n, what's b and a?
A is -2.
A is the -2,
B is 4.
and b is the 4, okay? So 4 minus a -2 over n, we've got a 6 over n.
Wait,
The
Okay?
-2 is lower, 4 is upper.
Yes, yes. So at this point, we're taking the limit as n approaches infinity of the sum from I equals 1 to n of f of a we said was -2 plus 6I over n times 6 over n. Now one thing I want to point out here that I saw some of you doing as I was grading our last quiz, some of you are forgetting that this is in the function. This a plus b minus a times I over n is getting us an x coordinate that we need to then plug into the function. Some of you were just multiplying that by the 6 over n and going on from there, okay? And that was throwing you off. So we need to actually figure out what f of that is, okay? So f of x is the 4 minus 2x. So f of -2 plus 6I over n is 4 minus 2 times a -2 plus 6I over n. Okay, so that's 4 plus 4 is 8 minus 12I over n. Okay, that is what we're going to multiply by the 6 over n. Okay, that is going in right here. So we've got the limit as n approaches infinity of the sum from I equals 1 to n of 8 times 6 over n is 48 over n minus 12I over n times 6 over n is a 72I over n squared. Okay? So we plug that in. That's the f of this times the 6 over n gives us this right here.
Okay, now we're gonna take the.
Okay? And now this process should be pretty familiar to us at this point. We're going to do the limit. We got to split up those sums. So, and I'm going to kind of do this all at once. The sum of the 48 over n is going to be 48 over n times the n.
Which is going to be just 48.
Okay, which will end up being just 48. This, it's a -72 over n squared times the sum of the i's.
And
The sum of the i's, we have the formula for.
n times n plus 1 over 2.
Over 2.
So
Okay, so here the I.
72 over 2.
Okay,
72 over 2 is 30.
36.
yeah. Okay,
Cancel out the n.
6, so it's 12.
so we're taking the limit now. The n's cancel, and that's just a 48 minus. We've got a 72n squared over a 2n squared
36n.
is 36. So 48 minus 36 is, what do you know? It's 12, just like we thought it would be.
Wait, it should be 36n. Because
No, no,
we
no.
multiply n by 1.
Well, you got an n squared. Well, remember, we're taking the limit as n approaches infinity. So the 36n
Oh, yeah.
is nothing compared.
So 12 is the area of that big triangle.
12 is the net area of these two combined. Just like we saw it was going to be when we did it geometrically. Okay? So this one we were able to do with geometry, and we found the exact thing. We also found the exact thing using the limit process here. Okay. So here we've got a couple of different things. Remember, if it is geometrical, you can use geometry. So what would our area, what would this integral equal?
4 times 2.
4 times
4 times
2.
2, okay? It's the integral from 1 to 2, or 1 to 3. So 2 times 4, that integral would be 8,
8.
okay?
What about like 12?
What shape is this?
It's a triangle and a
Trapezium or a trapezoid, or if you break it into a triangle and a rectangle, that works too.
That's what I
6
Okay.
and 9 over 2.
Okay. Let's review the trapezoid area. It's the bases, so the bases are 2 and 5 here.
Okay.
And the area of a trapezoid, remember, is the average of the bases times the height. The height is the distance between the two bases, which in this case is 3.
5 times 3.
So good, the average of the two bases is 3.5. 3.5 times 3 gives us 10.5. Okay?
Okay.
Here's a formula you ought to be familiar with.
That's the same.
Okay, x squared plus y squared equals r squared is our circle centered at the origin. Okay, so when you see a function where it's y equals the square root of something minus x squared, that is a half circle. Okay? That's the half circle. If it's negative square root, it's the bottom half of the circle. Okay? So, the integral from negative 2 to 2 of radical 4 minus x squared would be what?
1/2 area of
2
the
pi
of the circle.
2 pi r
BR
squared.
1/2 pi r squared, yeah.
That's it.
Well, what's r?
So R is 2
R is 2.
R is 2. So 1/2.
2 pi.
Oh, pi,
Okay.
2 pi.
So this whole thing is just
Put the pi.
2 pi. Okay? Now, these were nice because they were all just one function. Okay, and one piece that we could deal with. We also, though, have the additive interval property. Let me just illustrate this here with our function absolute value of x. Okay? So, if I were doing the absolute value of x, I would have this function right here. Okay? And if I were trying to find the integral from -1 to +1, I would be trying to find the area of these two triangles right here. Okay? Now, if I asked you to just do that geometrically, this actually would be intuitive for you.
Yeah.
You would find the area of the 1/2, which is
times it by 2.
1/2. And then you would find the area of the other side, which is also a half. Okay? And you would end up, well, no, they're both above the x-axis, so it'd be a half plus a half equals 1. But let's look at that from an integration standpoint. What this is saying is that if we have an interval going from A to B, stay with me for just a sec, if C is somewhere in the middle, we can take the integral from A to C, and then the integral from C to B, and add them together. So in this case here, what we're doing is the integral from -1 to 0. 0 is the C in this case, of the absolute value of x, plus the integral from 0 to 1. And that is the half plus a half equals 1. Alright, so we also have functions like this. What if we don't have a formula to work with? We have this kind of weird looking stair-step, half stair-step looking function right here. Okay? Well, I could find the area. If I asked you to find an area here geometrically, all of you would be able to do that, and you'd probably just naturally separate this up into different shapes. And how you did this might vary. Okay? But if I wanted to find this whole area,
I would be separated like a.
well, we're going to as well. I'm just coloring in the whole thing right now.
A square, a triangle.
Square, triangle, and rectangle. Square, triangle, and rectangle.
Yeah, so I actually want to look through this one geometrically, and then we'll do it. Okay? So yeah, we'd make a square here, and that would be, well, not a square, a rectangle. It'd be 5 by 6. So that has an area of 30. And then we could do a trapezoid here, because we're not afraid of trapezoids. All right? And what's the average?
Conquer my fear of
The bases are 2 and 6, okay? So the average of those would be 4.
Wait,
And it has a width of how far?
2.
2. Okay, so this has a height of 2, this has a height of 6. Average those, you get 4.
times 2 is
Times 2 is 8, so that's that.
38.
And then here's another trapezoid.
Wait, it's a trapezoid.
Oh, 2
Yeah,
is 6.
Yeah, it goes from 7 to 10, so that's 3. And on the bottom, it goes from 7 to 11, so that's 4. So the average of those is 3.5.
Yeah.
3.5 times the height 2 is 7. So there's that area.
5.
And then check this out over here. That's another trapezoid. Okay. Now look at this. The height on this one, though, because it's below, the height is actually -3. The bases are 3 and 4. So we've got 3.5 times -3.
Negative 9 over 2.
3.5 times -3. 3.5 would be 7 halves. Times 3 is 21 halves.
3.5. That's 3 over 2.
Where's the half?
3.5. So like
3.5 halves.
Trapezoids.
-21 over 2. -10.5. Okay. So total, I know that this integral equals 45 minus 10.5, 34.5. From a calculus standpoint, this is what we just did. We just did the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx plus the integral from 7 to 11 of f of x dx plus the integral from 11 to 15 of f of x dx. And that's what we were doing when we did the 30 plus the 8 plus the 7 minus the 10.5. And we got 34.5. Okay, so you guys can break these integrals up however you want, as long as it's continuous throughout the whole thing. Remember, it has to be continuous in order to be integrable. Okay? So, that's how we can use different intervals to find a full integral.